Next, I want to assemble this arm onto this pin on the base, and so I'll do a joint. I'll capture that position, and I'll select the between two faces for the component 1, between this face and this face. And for my snap point, I'll select this circle that finds the center point between those two faces on that hole. And then for second selection, I'll select the midpoint of this cylinder, and it moves that over into position, but I want that to be a revolution, and so I'll do revolute, and I see that it's revolving, but it's oriented incorrectly, so I'll go back to position and I'll flip that orientation, so now the teeth are in the correct direction. I'll say OK to that. If I test it out, so this moves as I would expect for around that axis of that pin. Alright, now I don't want to go through a big effort of recreating this same component 3 more times. It is slightly different for each one. I discovered an error in one of the dimensions for this part. Now you may or may not have made that same error. I'm going to make the lower left arm active, and I'm going to edit sketch 1, and let me just isolate this. So I'll right click and isolate that component. And then I want to check the angle between here and here. See, if it's symmetrical, this should be 10 degrees from here to here. So when I attempt to dimension that from here to here, I get an angle of 5 degrees, not 10 degrees. Now that bothered me when I created the part, that I didn't have to add a symmetry to there between this line and the line of symmetry, but I didn't double check it, so I should have double checked it when it bothered me. Now I'm going to delete this 20 dimension. And when I did, it moved my sketch relative to some capture position that I did, and I'm not sure if I'm going to be able to get rid of the capture positions or not. I'm going to come in here and put in a symmetry between this line and this line and this line. So I'll do symmetry, and I'll just continue. Now I can go back around, and I will select this line, then the line of symmetry. Now notice it all turns black, but I intend for a 20-degree angle between here and here. So let's try to dimension that. So I'll dimension from here to here, and notice that it's almost 30 degrees, 29.97. I want that to be 20 degrees. So even though this is all black without that dimension, I put in that dimension and it edits the part, and that's what I had intended. So the sketcher is not quite acting correctly somewhere in there. I was able to fix this though, so that now it is correct. So you may or may not need to make that same correction depending on whether yours was symmetric. And we can check this now. So if I dimension from here to here, we'll see that that's 10 degrees. And if I dimension from here to here, we see that that's the 10 degrees. So it's symmetrical at 20 degrees about this line of symmetry. I'll finish that sketch. I'll hide the sketch, and I'll check the flat pattern. Now I don't want to have to go through all of that sketching to create the other components. So I'm going to make a copy of this component and then edit the copies. So I'll right click and I'll do export. And I'm going to call this one lower right arm. And then I'm going to make sure that I tell it to save that project to the cloud and make sure the location where it's saving it. And so I have then this lower right arm is in my data panel. I will turn the rest of my components back on, undo, isolate. And so here are my components. And then I will place the lower right arm. And I can just put this any place on the screen. And then I'm going to, and why is that named? Why does it not show there? It should be showing up here. I made a mistake in that the lower left arm was still my active component. So when I dragged this over, it was putting that as a sub-assembly into this component. So make sure that your top level component is active, and then I can drag the lower right arm in, and I can move it around if I would like. And then I'll go ahead and constrain this component. So I'll do my joint, and I will select the mid plane between this face and this face, using that as my snap point, and then I'll select the midpoint of this pin, and we'll say OK to that. Now if we move this around, we may or may not be able to see that we have some interference, or that we can't get this in at the proper angle. If I line those up something like that, see, when the teeth are lined up, it should be a straight line across here over to here. So we need to change the angle on this part. The first thing I'll do is I'll right click, and I'm going to break the link to the copy that we put in the dashboard. Alright, then I'm going to isolate this component. So I'll right click and I'll do isolate, and I'll edit that sketch. And so I'll go to sketch number 1, I'll edit that sketch, and if you examine the original drawings, this angle for the lower right arm is 46 instead of 32. So I'll double click on that, I'll change that to 46, and we'll accept that, and that updates everything. And that's actually how I discovered my error with that 20 degrees when I went to edit this component. I'll finish sketch, I will check the flat pattern, I'll finish the flat pattern, and I will undo isolate. And so here we have all of our components. And so next we need to make the 2 upper arms. I will then export the lower right arm. So I'll do export, and again, make sure you tell it to save this to the project in the cloud, and I'm going to call this upper left arm. Alright, so let me export that, and I will make sure that my top level of the assembly is active, and then I'm going to drag in the upper left arm, and I can move it anywhere I want on the screen, and we'll put our joint in for this one. Now I'm going to join this with this component, and then I'm going to join it with this component last. And so I'm going to do my joint, and I'll go ahead and capture the current position, and I'll say mid-plane between here and here, and then I'll use one of these circles to get the snap point between those 2 planes. And then for the second component, I'll do mid-plane between here and here, and again I'll use the circle to define the snap point. I want a revolution joint. It's oriented in the correct direction, so I'll say OK to that. And so if I bring this up, we see that it moves the way we would expect it to. Now notice that this part is interfering with this part. So we need to make this narrower so that it will fit in between here and here. But let's go ahead and constrain it up here, and then we'll go and edit this part. So on this part, we could do it the same way, except that I want to allow this 2 degrees of freedom. So I want it to translate along this pin, back and forth in this case the Y direction along this pin, and rotate. Now it would do a revolute joint just fine, but we need to consider for analysis going forward in the future, there would be some clearance, and there is clearance between these various components, and this arm would be able to twist a little bit based on the clearance that's between this hole and this pin. So when I do my joint, I'm going to put it on a cylindrical joint so that it puts in 2 degrees of freedom, the rotational and the translational. It won't actually translate though because of the joint down here, but we need to consider how we put these joints in. So I'll do cylindrical, and really what I would like to do is a point line joint, but Fusion 360 doesn't have a point line joint. I'm tempted to do a ball joint instead of the cylindrical joint. Let's do that. I'm going to put the ball joint instead. So I'll do ball. So that's 3 rotational degrees of freedom. I want the least restrictive joint that I can put in here, and that would be a ball. So I'm going to do ball, and I'll go back to my position, and I'll say mid-plane between here and here. I'll use this circle to find that midpoint, and then for the second component, I'll select this midpoint of this cylinder, and so it shows those 3 rotational degrees of freedom. I'll say OK to that, but because I have the revolute down here, it only rotates around this pin. Let me get this so that's lined up, and I'm just lining up by eye. We'll have it lined up better here in a few minutes. Alright, so now it's a straight line across here because we changed that to that 46 degree angle. So we have 32 on one side and 46 on the tooth on the other side. Alright, so we need to edit this component. So right now it's too thick going through here. And so I'm going to break the link to the dashboard example, and then I'm going to go to that sketch, and I have to change a couple of items in the sketch. I also need to change the thickness, so I'm going to edit that sketch. And so for the upper left arm, this is 46, so that's okay, and all of these dimensions are the same. And so then I'm going to go to sketch number 2, and for the distance from here to this point is 0.815 on this component, and then we're going to make the part thinner, and I made this distance 1.375, and I really would have preferred to make this distance a function of the thickness of that part. Now I'm going to double click on this, and I'm going to do this as 1.345 minus parentheses 2 times 0.0625, the thickness of the material, close parentheses. And I should have done that in the original first arm that we did, and so that makes that thinner. We'll say okay to that, and then I need to change the extrusion thickness. So let's go to make this component active, and I will change the original extrusion distance, and I need for that distance to be that 1.345. We'll say okay to that. And so now this component is inside of this component. Notice that there is a little bit of clearance allowed from here to here, from here to here. So design clearances into your mechanism as you go. Don't wait till it gets out to the shop floor and assume that somebody's going to fix it after it gets to the shop floor. Now I'm a little bit concerned that these don't seem to be lined up now, and I'm not sure why it would do that. Those should still be lined up, so I'm going to have to put that joint in again, and I'll also need to check this one. It looks like that one is going through the center up here. So let me find that joint, and so that will be this revolution joint. Let's just do edit and see if we can figure out why that's showing up in the wrong position. So I went back to edit that joint, and I noticed that the snap point is no longer in the center of the circle. So I'm going to select this circle again, and it still isn't in the center there. So I'm going to do this a different way. I'm going to turn on the visibility of those two sketches. So for the lower left arm, I'll turn on sketch 1, and for the upper left arm, I'll turn on the visibility of sketch 1. Alright, so I have those two sketches visible, and then I will edit that joint, and I'm going to select for the first one, so I have between those two planes, and then for the snap point, I'm going to select this point right here. And then I'll go to the second component, and the two faces on either end are selected. And then for the snap, I will select this point. So it's down here for some reason. I'll come up here, I'll select here. Alright, so now when I look at this from the front or back view and do the animation, we see that it's revolving in the same place. So I should have been more careful with that back when I initially put in that joint. So I'll say okay to that, and I'll turn off the visibility of those two sketches. I'll turn off the sketch in the lower left arm and the upper left arm. So let's check this flat pattern, make sure that that still gives us a flat pattern, and it's failing on the flat pattern. I'll try to fix that, but I'm not sure that we'll be able to fix it. I'm going to delete that flat pattern. I will delete the convert to sheet metal, and I'll convert that to sheet metal again. So I'll do convert to sheet metal. I'll select this component, and it finds the thickness. I'll say okay to that, and then I'll try creating the flat pattern again, and so I'm able to recreate that flat pattern. I'm not sure why we have to go through those steps in order to redefine the sheet metal part after making a change to the geometry. Alright, so I need to go through and double check everything now, make sure that I have everything centered here. I have everything centered here, and everything's okay here. Alright, so then we need to create the upper right component. So I'm going to make a copy of the lower left to do the upper right. So I'll right click and I will export this, and I'll do this as upper right, and make sure that you save that to the project in the cloud. I will then go to my data panel and I'll right click and I'll insert that into the current design. Make sure though that the top level of the assembly is the active level. Do insert into current design, and if we want to we can drag this up here. And so again we'll do our constraint, and I think the first thing I'll do is break the link. Now there may be reasons to not break the link to the original if you're going to use that in different assemblies. And then I will do my joint, and I'll select symmetric between here and here. And I want to pay attention to this now. This time I didn't pay attention the first time. For my snap point, I want the center of this circle, and it looks like it's not picking that center of that circle. So I'll select this cylindrical face and see if that does it. I need to go to the front view, and so that did it. So I don't have to turn those sketches on. I just need to select that cylindrical face, and then I will do mid-plane between here, and again for the snap select this cylindrical face, and then I want this to be a revolute, so I'll put it on revolute, and we see that it's revolving correctly, but I need for it to be 180 degrees from that. So I'll go to the position, and I'm going to flip that position, and I'll animate it again. So now it's correct. I'll say OK to that. Let's drag it up here into position about like that. Alright, so it's rotating about these centers. Alright, then I'm going to do the joint up here. So again, I'll do my joint, and I will select mid-plane between here, and I will select this cylinder. And I'm just going to start selecting cylinders all the time instead of these circles. I'll select that cylinder, and then for the second component I'll do mid-plane, or actually because it's a cylinder I can just pick the center of that cylinder, and I want that to be a ball joint. So I'll select ball. That gives it 3 degrees of rotational freedom. Then we need to edit that component. So let's save it. It's been a while since I saved it. And I'll make that component active, and I'll go to sketch number 1. I'll edit sketch 1. So on sketch 1, the angle for this is 32 degrees, so we don't need to make a change on that. And then the angle here is 28 degrees. We'll finish that sketch. I'll go to sketch number 2. I'll edit this sketch, and so this distance is 0.815, and then the distance for this dimension is the 1.345 minus parentheses 2 times the thickness with 0.0625. And really we should tie all of this together with named parameters, and that way we just change the named parameter rather than typing in individual formulas. Like, I'll finish that sketch, and then I'll expand this, and I'll go to that first extrusion. I'll edit that feature, and I'll change that to the 1.345, and then we'll check our flat pattern, and it gave us an error on the flat pattern. So actually let's try one other thing, and I'm going to go to tools, and I'm going to recompute all, and I still have an error on this flat pattern. I'll delete this flat pattern. I will delete the convert to sheet metal. I'll reconvert that to sheet metal. So we'll go to sheet metal. I'll say convert to sheet metal. I'll select this part, and then I'll do the flat pattern, and it solves the flat pattern. Alright, so we have everything working now. Next we need to put the hardware that goes in between here. And by the way, if we look at these teeth now, let's go ahead into a section view. So I'll go to the XZ plane, and I'll do a half section on the XZ plane. I'll turn off that plane now. And so if we examine these teeth, if I've done my job correctly, there shouldn't be interference between these teeth. And so we'll move this up and down, and so we see that it comes down, and then I'll move it up, and we see how those teeth mesh then as the mechanism goes up or down. There's a little bit of clearance between those teeth. We can't make perfect parts in the real world, so some are going to be a little bit larger, some will be a little bit smaller, so we need to make sure that we design appropriate clearances in between our components as we're doing the design. Notice there's also a little bit of clearance between this pin and the hole in that part. There's another location where I want to check, and actually I guess we need more of the components in here. I'll leave analysis. So when we put the components that go across here, the hardware, we need to also make sure that they don't intersect here or here on these arms. We saw how to recover from several issues in this video. It's not enough to just watch a video to gain the recognition and the experience of how to resolve issues. You must do the work. You must practice, practice, practice. When it comes time for a certification exam, you should have the confidence that you can address any issue that arises in a timely manner. You gain this confidence in only one way: by practice.